Hi, in this podcast we're going to do more examples with equations. And remember, I'm following the Mathworks 12 textbook. I'm going to look at the building your skills and do a couple of the even questions just to sort of go over some of the points again just as a review. So in this question here, we're going to look at solving the equation or creating an equation that would represent this relation. So in looking at the question, first of all, I can see that there's going to be a flat rate. And whenever you see that an initial flat rate on top of a salary per hour, it's a good indicator that we're looking at a partial linear equation. And remember, we're going to be using a different equation to solve partial linear relations. So, and that's because the B essentially takes into account the flat rate. Okay, but we're going to look at some examples, and then obviously you'll have a chance to practice some more of these. So looking at this example, initially for the contractor, just for the shed itself, so for no hours, just for the shed, the contractor is going to charge $4,000. However, in order to do the painting as well, he's going to charge an additional $35 an hour for the painting. So we can almost assume that at zero, the flat rate will be $4,000 for the shed. And then if the guy didn't want the painting done, that would just be the price. But for every hour, the price is going to go up. So at zero, the price is $4,000. At 1, the price will be $4,035. After 2 hours, the price will be $4,070. After 3 hours, the price will be $4,105. And if the painting took 4 hours, the price would go up an extra $35 to $4,140. So that's the relationship that we've made. And of course, we could graph this. And if we were going to graph this, what we would see is that our y-axis would be the cost, okay, because we don't really have control on the cost. The rates have been sort of pre-selected. But where we do have control is in the amount of time. So if we have a small job that may take less time, it's going to cost us less than if we had a large job that takes a lot of time. So time is something that we can alter. And so what we would notice is that on our graph, at time 0, we're starting at $4,000, and that's just the flat rate for the shed, and it's going to go up in a linear relation. And remember, it's only going up by about $35, so I wouldn't expect that line to be that big, and I also wouldn't expect the slope to be that large either. But let's quickly calculate the slope, because I want to show you a relationship between the numbers that we're dealing with in the question and the actual mathematics to it. So remember, to calculate the slope of a line, we take a point that's later minus an initial point on the y, and we do the same on the x. Now I'm going to make this really simple, and I'm going to choose this point here and this point here. I don't expect you to do anything else other than simply choose the easiest points. And so if I was to choose those, remember the y's are going to be my costs. So that equals 35 minus 4,000, and that's going to be over my x. Now my x2 is 1 hour, and my x1 is 0 hours. So when I take 4,035 and minus 4,000, I get 35, and 1 minus 0 is 1. So in other words, my slope for this line is equal to 35 over 1, right? So $35 for every 1 hour. Now, let's go back up to the question, because there's something here that I want to show you. This $35 an hour in a question is my rate. And remember that my rate is really just the slope of my line, if it was a linear relation and if I graphed it. Okay, so this number here is equal to m in my equation. And remember this number here, and I'm going to show you the solution for this as well, but this number here we're going to find is equal to that b in the equation because it's a partial and because there's a flat rate. Now, if this was a direct linear relation, then that b would be 0, right? The y-intercept, or where it meets the y-axis, would be down here on the graph. So that's a quick way to look at, or another way to look at these equations mathematically, is to really understand what they're saying. But the question's asking for the equation, so let's write out the equation. So in this case, the equation is y equals, we've discovered our m to be 35x plus, and remember we have a flat rate of $4,000. Okay, now what I want you to try to do with this question is to solve this value and really see if it is. So remember to do that. We're going to substitute in a value, one of our sets, and let's pick the first one. Let's pick 0, or let's go to the second one. Sorry, let's pick 4,035. So that will be my y, right? The cost. 35, and my x value is 1 plus b. And what I want you to do for this question is to stop the podcast or pause the podcast and try to solve for b. Okay, hopefully you got the answer you were looking for, and hopefully you found out that that $4,000 is in fact the y-intercept, or b, in the equation. We're going to do one more example, and that's number 6. And so in number 6, we're looking at comparison of 2 monthly phone plans. Company A is looking at a constant rate of 35 cents a minute, and Company B is got a flat rate of $12 and 18 cents a minute. So right away, looking at these two sort of phone plans, that right there will be a direct linear relation. There's no flat rate to it. This one here is going to be a partial. So for part A, write an equation describing each company's phone plan. So let's look at Company A, because that's easy. Company A, where y is always equal to my cost, in x in this case, what I can change is the amount of times I, or the length of time that I spend on the phone, so that's my minutes. And remember that I showed you on the last example that this number here is my slope. And we can always calculate that out if we wanted to, but that's my rate, 35 cents per minute. This equation for Company A will be y equals 0.35x. Remember that b in this case, the plus b, in the equation is 0 because we start at 0. We're not dealing with a flat rate. If we look at phone company B, again, y is equal to my cost, x, obviously be my minutes. The m, that's my rate. So in this case, it's 0.18 per minute. And then we have this flat rate. The flat rate is a B, and the flat rate is $12. Okay, so when I write this formula, I have to put the B in. So this formula says that y is equal to 0.18x plus 12. Okay, now, last thing we're going to do is the last part of this question, and I'll scroll up so we can see it. So Sue is going to use the phone 60 minutes each month, and we want to know what plan would be best for Sue. So what we're going to do is we're going to plug in these, that number, 60 minutes, into each of these equations. So let's look at the first one. Y equals 0.35x. Now remember, x is equal to the minutes, so we're just going to substitute in with 60. So 0.35 times 60. Okay, and when we do the math, 60 times 0.35 is going to be equal to $21. So it's going to cost Sue $21 on that plan. Let's look at the other one. So in the other formula, y equals 0.18x plus 12. So y equals 0.18 times 60 plus 12. Now remember our order of operations. The order of operations says I have to do that first. Okay, so when I take 60 and times it by 0.18, okay, I get y is equal to 10.80 plus 12. Okay, so when I add 12 to that, my y is equal to 22.80. Okay, so in comparing both of these plans, it looks like plan A would save her the most money, right? Because $21 is less than $22.80. So she should choose Company A's phone plan to save her some money. So that's the end of the podcast.